Hi guys, welcome to Calculus Crush. Today we're going to be taking the derivative of the following function, f of x equals the square root of 6 minus x. But we're not going to be using the chain rule here. We're going to be using the definition of the derivative, the most basic rule, and this is going to end up being quite a long question. This is a very fast question if you know the chain rule. You can do it in 1 or 2 lines. But using the definition of the derivative, it's going to take a little bit more work. So let's start by writing down the definition of the derivative, which is f prime of x, which designates the derivative, is equal to the limit as h goes to 0, f of x plus h minus f of x, all divided by h. If you don't know where this comes from, this is the definition of the derivative, and if you click on it, you can see a derivation, exactly where this formula comes from. So let's continue. F of x plus h, we just go to our f of x. Everywhere we see an x, we need to replace it with x plus h. So start off with limit as h goes to 0, and it'll be 6 minus, in brackets, x plus h, and this whole thing is under the square root sign. So that's f of x plus h, minus just f of x, 6 minus x, square root. And this whole thing is divided by h. Okay. Now, this is where we start to run into some difficulty. What do we do with the numerator? We know from previous experience doing these problems that we need to somehow get an h out from this so we can cancel out the h over h and get rid of the 0 over 0 problem we have with all of these examples we do using the definition of the derivative. But we got these root signs here. So what we're going to do is rationalize the numerator. Now you rationalize the numerator by multiplying the top and the bottom, the numerator and the denominator, by what's called the conjugate of the numerator. And the conjugate of the numerator is simply the numerator with a plus sign between those two terms. So I'm actually going to do it up here at the step before. So we're going to multiply this by 6 minus x plus h square root plus, that's the important part, plus 6 minus x. And we can't just go around multiplying the numerator only by stuff. We have to, whatever we do to the top, we must do to the bottom. Otherwise, we're completely changing the expression. Six minus x square root. So this entire term here, it's something divided by the exact same thing, so it's just equal to 1. So you can convince yourself that we're not actually changing this formula or changing this this function here. We are only multiplying it by 1. We're doing it in kind of a fancy way. So let's see what we get at the top here now. So we've got the first term times this. Now these are the same term. They're the same value. So when you multiply them, you just end up getting rid of the root sign. We're going to need more space to do this, maybe. Move it down a line. Equals the limit as h goes to 0. So we've got this times this, which is the same thing, just without the root sign. Now, the reason why this rationalization or multiplying by the conjugate works is because we have no cross terms, right? So if we take this term multiplied by this one minus this term multiplied by this one, they just cancel out. The cross terms are gone. All we're left over with is the last two terms multiplied together. So that'll be minus, and 6 minus x square root times x minus x square root is just 6 minus x. We need brackets around that. So we've rationalized the numerator here. Now on the bottom isn't going to look so pretty. We've got our h, and then we've got all this stuff here. So let's rewrite it. 6 minus x plus h square root, and this whole thing is under the square root sign, plus 6 minus x square root. I'll use big brackets here. Okay, so let's keep going. Now the next step, limit as h approaches 0. Let's expand the top here. So we have 6 minus x minus h minus 6 plus x, all divided by h 6 minus x plus h square root plus 6 minus x square root, all in brackets. All right, so let's cancel out some stuff on the top here. Well, we've got a positive 6 and a negative 6, a negative x and a positive x, and all we left over with is a minus h. The limit as h goes to 0. So all we've got on the top, actually I'm going to write the bottom first because the bottom's way bigger than the top. H, big bracket, 6 minus x plus h, all square root, plus 6 minus x, square root, close the big bracket, and we have a minus h on top. So now you can see that rationalizing has allowed us to bring out an h. Well, in fact, all there is on top is an h. We can cancel out the h over h, and that gets rid of our h over h problem. Our 0 over 0 problem. So let's write the last step before we take the limit. Once again, on the bottom, well, now we don't have the h. All we've got is 6 minus x plus h square root plus 6 minus x square root, and that's all divided by minus 1. Okay, I'm going to move up here. Now let's take the limit as h goes to 0. So wherever we see an h in here, we need to make it equal to 0. So what we end up with, once again, I'm going to write the bottom first. 6 minus x square root plus 6 minus x square root and a minus 1 on top. And the final step, these two are the same, so there's just two of them. Minus 1 divided by 2, 6 minus x square root. So we'll finish this off. F prime of x is equal to negative 1 over 2 times the square root of 6 minus x. Now you can write this other ways. I think this is probably a pretty nice way to write it. But we can also write it this way. F prime of x is equal to negative 1/2 times 6 minus x to the power of minus 1/2. So remember that the square root is just the power of a half. And if something's on the bottom of the fraction, the power is negative 1. So it gives it a minus 1/2. Now, if we were to actually solve this derivative using the chain rule, which is the normal way you would do this. You would never really use this method. It takes too long. Using the chain rule, your answer would come out just like this. And then you could write it like this if you wanted, or you could just leave it. Depends what your professor likes or what you like. Now, one more thing I want to mention before we end this video is some people may be confused why the multiplication of these two numerators here gets rid of all the root signs. So when we rationalize, the basic idea is if we have a plus b and we multiply it by a minus b, that's going to be equal to a squared plus ab, let's do this the right way here. So the first one, a times a, gives us a squared, minus ab, plus ab, minus b squared. So you can see that those cross terms cancel out, and all you're left over with is a squared minus b squared. So in our case, a and b were square roots. So when we have an a squared, we just get rid of the square root. Okay, guys, thanks for watching. Hopefully this helped you out. If you have any questions, just leave them in the comments section. I'd be happy to answer them. Until next time.